Champions, a very warm welcome to this brand new session on your favorite channel BYJU'S. And today we'll be studying another very interesting topic from this chapter, metals and non-metals. So today we will be exploring the chemical properties of metals and non-metals. So this is part 1 of the chemical properties. We've already done physical properties, right? So now it's time to go ahead to move on and understand the chemical properties as well. But before we dive straight into it, we have something for all of you. BYJU'S mini learning program currently is absolutely free. All you have to do is use this code YTFREE, and this offer is ending really soon, guys. It's ending on 17th of July. So quickly avail this offer and unlock all the premium features for free. So the introductory pack of 3 sessions, that's going to be absolutely free for all of you if you will be using this code YTFREE. And yes, this is ending on 17th of July. So right after this session, my suggestion is that go check this out and actually experience all the premium features that we have here at BYJU'S. So go ahead and try this out till the time it is absolutely free. Alright, now moving on to the contents. Today what are we going to talk about? We will be talking about reaction of metals with oxygen, reaction of non-metals with oxygen, reaction of metals with water, and reaction of non-metals with water. So in a way, reaction of metals and non-metals with oxygen and water. But before we start with the chemical properties, let's quickly recall the physical properties of metals first. So in the last class, we talked about the physical properties of metals and non-metals. So I hope you all remember that metals are malleable. That means they can be beaten into sheets. They can conduct electricity. They are good conductors of heat as well. They are ductile. That means they can be drawn into wires. They are sonorous. That means they are going to produce sound when hit with a hard object. Moreover, we also talked that metals are lustrous, they are hard, and all these properties are generally applicable to metals. You know, in chemistry, we very conveniently use the term generally. So yes, a lot of exceptions are there, but generally speaking, all this is applicable when we talk about metals. So physical properties, we know it all. So I can put a smiley face out there. Now it's time to understand the chemical properties of metals and non-metals. And in chemical properties, we will be talking about reaction with oxygen, reaction with water, reaction with acids, and reaction with bases. But in today's class, we are going to master 2 types: reaction with oxygen and reaction with water. So let's get started with this topic. Alright, first of all, reaction of metals with oxygen, and then we'll talk about reactions of non-metals with oxygen. So, say suppose we have a metal magnesium with us. I hope all of you are aware of the fact that magnesium is a metal. Now, when magnesium burns in the presence of oxygen, what happens? Have a look over here. A white dazzling flame is there and a white powder is being produced. So in a way we can say that magnesium, that's Mg, burns in the presence of oxygen, that's O2, to form the corresponding oxide, that is magnesium oxide, MgO. So that white powder is MgO. And this magnesium oxide actually forms a base with water. So in a way, we can say that metals react with oxygen to give the corresponding oxide, to give the respective oxide. So this is going to be the general equation for the same: metal reacting with oxygen to give you the metallic oxide. So magnesium is a metal, we all know. Similarly, sodium is another metal that is also going to react with oxygen to give you the corresponding oxide, that is sodium oxide, Na2O. Now, these oxides are generally basic in nature. That means if you take a red litmus, that red litmus will change to blue, indicating that these oxides are basic in nature. So yes, you can say that generally metal oxides are basic in nature. Alright, so now we know how metals react with oxygen. I hope everything is sorted till here. Let's see how are non-metals reacting with oxygen now. Now over here, let's say we have a non-metal sulfur with us. In the presence of oxygen, What is it forming? It's forming the corresponding oxide, that's sulfur dioxide. Now, when this sulfur dioxide is added to water, what is happening over here? Well, it is forming the corresponding acid. So, sulfur dioxide plus water will form the sulfurous acid. I know what you're thinking. You're thinking, sulfuric acid क्यों form नहीं हुआ? वो उसके बाद होगा. But initially, sulfurous acid is being formed. Now, it's an acid, right? If you will check the nature, you will definitely understand that this is acidic in nature. So, if you take a blue litmus, dip it in sulfurous acid, it will turn to red, indicating that non-metallic oxides are generally acidic in nature. So, over here, definitely we can say that non-metals react with oxygen to form the corresponding oxide. For example, we have the non-metals, say carbon, that's reacting with oxygen to give you the corresponding non-metallic oxide. What is this going to be? Well, this is no rocket science. It's going to be carbon dioxide. Now, we also just studied that oxides of non-metals, they are generally acidic in nature. So with the help of a litmus paper, we can easily figure that out. We can easily figure out the nature, right? So there you go. Now we know how the reaction with oxygen is taking place. So we are done with this, and now it's time to understand the reaction with water. So again, we've divided this in two parts. First, reaction of metals with water, then reaction of non-metals with water. We'll start with the former. Suppose we have sodium metal with us. So metals like sodium has a symbol of Na, and potassium, that is K. They are very, very reactive metals. Have a look over here. What's happening? They are reacting vigorously with water, right? And they're catching fire. And these metals, they react vigorously with oxygen also. And that is the reason we are saying that they are very, very reactive metals, because they react very vigorously with oxygen, with water, and because of that, we are actually storing them in kerosene. So they are immersed in kerosene for this reason, so that we can prevent the accidental fires. And there you go. Whenever next time you go to the chemistry lab, please notice how is sodium being stored. Now you know the reason behind this also. So it is always stored in kerosene, because otherwise there could be fire, right? But the question here is, do all metals react vigorously with water? Are all metals stored in kerosene? Well, the answer is no. Different metals have different reactivities with water. I just now told you about sodium and potassium. They are very reactive metals and they react vigorously with water. But we've got other metals also. So metals like zinc and iron, they do not react with cold water. In fact, they do not react with normal water also. And with steam, they react very, very slowly. So they are basically reacting with steam really slowly. Then there are other set of metals also. Like for example, we have copper, we have silver, we have gold. Now these metals do not react with water at all. So you must have noticed that different metals have different reactivities with water. Alright, so now we know how metals are reacting with water. Next, it's non-metal's turn. So let's understand what is happening when a non-metal is added to water. So suppose coal is added to water. Now over here, what is happening? I mean, even if we'll keep waiting over here, do you think something is going to happen? You take it to be carbon, okay? Carbon in water. What is happening? Well, you'll keep waiting, still nothing would happen, because generally non-metals do not react with water. In fact, they're actually stored in water. So you'll actually notice that phosphorus is stored in water. Why is this happening? Why are we using water to store phosphorus? Well, some non-metals are very reactive in air. And phosphorus is one of them. So phosphorus is a very reactive non-metal and it catches fire when it is exposed to oxygen. That is in the presence of air. So to prevent the contact of phosphorus with the atmospheric oxygen, what are we doing? We are actually storing it in water. So I hope now you know why sodium is being stored in kerosene, why phosphorus is being stored in water. So this session was all about really specific examples. So go back, watch the session again, because a lot of questions can be asked in the exam based on this. And with this, we've come to the end of this short session. And for the PDFs, for any kind of uploads, you can join Telegram Telegram and get all of that instantly. So if you've not joined Telegram yet, quickly go join Telegram. You'll get the revision questions, session notes, session PDFs, really interesting facts, and of course all the updates. So we will be joining you there as well. I hope you'll also be really excited to join us. So yes, we can connect on Telegram as well. And I have a homework question for you, so don't go anywhere, okay? Now, we keep telling you that we've got you covered and we'll be back with amazing sessions. We'll be back with such sessions wherein your concept clarity is on point. So stay tuned, stay connected, and yes, of course, you know that this mini learning program is going to end soon. That is 17th of July. So quickly tell your friends to avail this offer YTFREE. I hope you've done it by now. So you can spread the word. You can let your friends also know about this. Because by using this amazing code YTFREE, they can actually unlock all the premium features just like you. So I know you've enjoyed all the sessions. Tell your friends, tell everybody around so that they can also gain out of it, right? And this is ending on 17th of July. So quickly, really less time is left now. And yes, finally, I want all of you to do one thing. I told you I'm going to give you a homework question. In the comment section, I want all of you to tell me which acid will be formed when carbon dioxide reacts with water. Really simple question, right? Let's see how many of you will be able to answer this. Which acid will be formed when carbon dioxide reacts with water? I'll be waiting for your answers. And before closing this session, I hope you've already liked this video. If not, quickly like this video, hit the subscribe and share button as well. And keep working hard, keep smiling. I'll be waiting for your answers and I'll see you super soon again. Take care, bye-bye.